Associate Professor in the Department of Electrical and Computer Engineering, Communication and Information Engineering Division at the National University of Singapore. He also served as the Chair of the Computer Engineering Program at NUS. Professor Bharadwaj received his master's degree in Electrical Communication Engineering and his PhD from the Department of Aerospace Engineering, both from IISc. He received gold medals for his bachelor's degree and for an outstanding PhD thesis. His research interests span a wide array of domains, including cloud, grid, and cluster computing, scheduling in parallel and distributed systems, including distributed satellite system, AI-enabled edge computing, cybersecurity, as well as machine learning and deep learning for computer vision and image processing. He is also one of the early pioneers in the field of divisible load theory. He has served on the editorial boards of several prestigious journals, including IEEE Transactions on Parallel and Distributed Systems, IEEE Transactions on Computers, IEEE Transaction Systems, Man and Cybernetics, and IEEE Transaction on Cloud Computing. He is a senior member of the IEEE and IEEE Computer Society. So today he will be joining us virtually and speak on the topic network-based computing. Professor, over to you.
Yep, thank you. Good afternoon, everyone. Let me first thank Professor Ashwini for this massive initiative recognizing Professor Debashi's contributions. Well, this is by no means an easy task at this scale. And what I was totally thrilled when I received his first email last year sometime about this plan of organizing a conference and asking a few of us on potential ideas and topics to participate and all that. And above all, what really kind of hit me was just to realize how fast the time flew by. So here I am today, honored to virtually present my reflections on my PhD work carried out probably 35 years ago with Professor Debashish and Professor Bhimani. As a matter of fact, well, I hold a very special place in Professor Debashish's line of students. Yes, I'm his first PhD student with a chance of, I was lucky to interact with a very young Professor Debashish Ghosh. And I'm ever grateful to him for that training and experience. Today, I'm going to share my reflections on my PhD work in the domain of network-based computing, also known as distributed computing, as today, many of us know that network-based computing also embraces a larger span of computing platforms like grid, clusters, and clouds. So let me highlight some significant works I carried out with him and also show their influence in setting up my career and how it allowed me to progress as an academic researcher all along. So the agenda for my today's talk is this. I'll start with my PhD pathway, which started in the year 1992, January to 1994, about April, about there. And then I'll talk about the network-based computing, how it all started, how I came in touch with Professor Ghosh, and reflections on my two major contributions and their usability and impact till date, and some take-home points. Well, let me start this. Actually, I was a graduate from EC department, IISc, back in 1991. And I had a lot of passion in the electromagnetics domain, because I was a physicist, my bachelor's degree. And I had a lot of interest in optics. And my final year project was in wave propagation through waveguides. And at that time, people are talking about the all optical interconnects and fully optical computing machine and all that. So, and I also was very passionate about differential equations and their use in different application domains and all that. So after my master's, I was talking to my professor Selvarajan in EC department, and I was told that there is a possibility to pursue PhD with EC department under his guidance from August 1992. So that gave me almost an year's time. So I took a break, and then I joined a telecommunications company in Madras, a software company. And that's where a big realization came to me. I realized that that type of job was not kind of fitting me in any way. So that was my state of mind, as you could see the screen. So the y-axis capturing the frustration levels, and the x-axis telling me the time to write a hello world program. So that was sometime in July 1991. And during my master's days, I came in touch with Professor Mani because he was living in the PD hostel next to our Gymkhana, because we had some common friends, and that's how I came in touch with Mani, and Mani became my good friend. And I expressed my interest to pursue PhD, and then he was kind of encouraging that. And he came to Madras around September, mid-September somewhere. And I had a telephonic conversation. In fact, I have visited him, and he was sharing all about his research with Professor Debashish Ghosh on onboard computing, image processing, and distributed computing domain, and all that, and how his work is kind of applicable to a broader domains and all that. And it was simply a kind of a very motivating fact for me. And then by the time mid of October, sometime, my frustration level was very deep. So I decided that I should give a try, and I expressed my interest to join aerospace. Then, well, I applied to a department, IISc, in the year 1991, sometime in October. And the interview was, PhD interview was in October, November 1991. And then, well, bingo, I got the seat, and I was very, very excited to join this team with Professor Debashish, and you can see his photo here, and that's how he looked at 1992. All right, so this I took it from my old memories. So I was back to school. Well, after joining, so what's up? So at that time, it was just the end of the Gulf War, 1990, 1991. So for the first time, I was hearing all about the Scud missiles and stealth technology and all that in place. I was discussing with Prof. Debashish. I could see the pictures, which I'm showing on the right-hand side, vector, all these vector pictures, like missile, line of sight, target, and all that. And he was working in guidance, missile guidance and all that. And he was also talking a lot about this, his theory on missile guidance, using was true proportional navigation and all that. I mean, I vaguely remember all this. Then, but as a man, I mean, he was giving me a complete flexibility to choose between this or distributed computing and all that. And that was, and then I was discussing with him which one to choose. You know, so as a student, I'm not aware of any of these domains and their impact in the future. So he was giving me a complete overview of all these and knowing more about my interest in the differential equations domain, and he said that I'm free to choose. And in another discussion, something like this. So using a network of computers, still the missiles were kind of guided, and Mani was also telling me about, like, okay, maybe if I embark on distributed computing domain, I'll be able to cover up a major application areas and all that. Then I weighed against pros and cons, and then I said, like, fine, why not try this domain? And that's where I entered this domain. So when I entered, as I mentioned earlier, Professor Mani and Debashish were already working in some fundamental problems in the distributed computing area. And that was on these data parallel application models. So, well, I was introduced to this model in a more formal way. In fact, Professor Mani was already deriving certain things on Ethernet-based networks and all that. So I was able to get a hang of what they were doing actually. And then, well, I embarked the journey from that time. And basically, the divisible load models are very specific models that are applicable for data parallel computations. And strongly, they rely on the following assumptions. One is the workload was assumed to be kind of arbitrarily divided, and you can assign to any of the computing nodes in a parallel platform. And then another strongest assumption being that there are no causal relationships. Once you split the jobs can be independently processed on that node. So these were kind of assumptions that were used to develop the model. So having said that, we looked at the communication and computation way of handling, like the different types of configurations, because you can actually compute and communicate simultaneously, or you can compute, or you can communicate first and then compute. Well, with all this mix and match, we were able to do some kind of analysis. So that's how I started doing my very first work in deriving and estimating how much amount of computation load should be assigned to each of these computing machines. And then the whole objective being to minimize the entire processing time of the entire load. So that was the objective of the work. So, well, the model was pretty much used a linear model where we assumed that the computation delays and communication delays are proportional to the amount of load you are assigning. And later, after I graduated, I looked at refining these models by including some of the affine models. So where I also I've considered some overheads associated with this entire process of communication and computation. Now, my first work started with considering more generic a single level tree. Well, because Professor Debashish and Mani were kind of working on Ethernet-based networks where there is just a single link, a communication link, whereas in the case of single-level tree, you have several links connected to a distributor node, which is the root node, where we assume that the entire workload arrives. And then based on a strategy, as shown in the timing diagram here, the distributor node goes on distributing different chunks to the processors. And each chunk, when it travels on the link, it experiences delays. And then when it is received by a processor, it encounters the delay for computation. So based on this strategy, an earlier work, which is purely based on empirical study, claimed that when you force all the processors participating in the computation to stop computing at the same time, as I shown here, that is claimed or perceived to be an optimal solution, although there was no formal proof at that time. So, well, we derived how much load to give to each processor for all the processors that are participating in this work. We derived, and that was kind of a first step towards assuring that, well, there is a possibility that we can derive some closed form. So the significant results include, we took this empirical study, which was published in the year 1988, and formalized it, like giving a very more mathematical formal treatment in the year 1991. And when I joined, it was applied to single level tree. We were able to derive a closed form solution, which means that the amount of load that you want to assign to a processor becomes a function of node and link speeds. And this was a kind of a breakthrough, I would say, because if you're taking your workload to any network, all that you need to know is what's the link bandwidth and the processor speeds. And then when you plug it in, you get those fractions. So it becomes a very easy go for an administrator. And therefore, you can actually estimate the processing time, which is perceived as an optimal processing time as a function of node and the link space. But this was, I would say, it's like probably an easy first step. Now, the most interesting thing happened after that, the proof of optimality. Then Professor Debashish said, like, why do we believe that this is an optimal solution? So how do we prove it, right? So although it is there as a proof in a visual way, I would call that my epic celebration period, right? So right in the first year, a student enters, right in the first year, there is an epic celebration period. So that's where we spent about like 7 to 8 months, loads of lemmas. All right. So I'm sure Prof. Debashish, if he's hearing this, he would recognize that 7 to 8 months. Almost every day, I come up with one argument, and he comes up with another argument, and then as a professor, he definitely encourages in the sense that he agrees with me and then fine tunes my thinking, and then probably at the end of 7 months' time, or 6 to 7 months' time, we hit on the ultimate proof of optimality, saying that indeed, by forcing the processes stopping at the same time is an optimal solution. Well, that was a breakthrough, and in fact, that formed a bigger chunk of my thesis. As an offshoot of this exercise, two intriguing dues-inspired questions came up. The first question is, as you see here, the picture, I put this in the pink curve line. So the distributed node starts distributing the load from P1 to PM in that particular sequence. So when you start distributing in a particular sequence, we were able to tell the optimal solution. So the question now Professor Ghosh asked me was that, what is the optimal sequence? So because you have n different nodes, so you are trying to search an optimal sequence in a space of size n factorial. So what is the best sequence? So for every sequence, of course, we know the optimal solution. So, but what is the best sequence? Then again, I would say a smaller epic celebration period where we proved that the sequence, we identified the sequence and the property, and it became an optimal sequence theorem, and which the later publications they have used in a variety of situations. So the sequence says that, okay, if you start distributing along the fastest link to slowest link, that becomes your best sequence. Then the second question is, the first question is, it doesn't disturb the infrastructure. So given an infrastructure, the administrator is allowed to choose a best sequence and then distribute. Whereas if a question like, if I'm giving you to dismantle the network and allow you to come up with a configuration, what would be the best possible connection that you would suggest? So that becomes an arrangement. So we are talking about an arrangement of this single level tree where the theorem, again, we proved is that connect the fastest link to the fastest processor and distribute. And that became an optimal arrangement. So these two results became quite influential in the literature for the theory papers that came after this. And by the end of, when we consolidated all these findings, almost in very early 1993, I was able to submit a solid theoretical paper carrying richer amount of results, which are also used in SPI to IEEE transactions on parallel distributed systems. Well, then we continued this work, and then we started looking at resource optimization, right? The birth of multi-round strategies. So let me explain this. So this was the first kind of attempt in my first work, in the first year. And as you could see, I'm pointing out to this processor cycles wasted. So Professor Debashish was asking me this question, like, is there a way to minimize this? So if you are able to allow the processes to start earlier, then they will finish earlier, right? So that's a very straightforward logic. But then he put a very killer question: why not supply the loads in multiple rounds, right? So that is something like you supply the loads in multiple rounds. So each round will take smaller chunks, but then each processor will start earlier, and which means that they will finish earlier. So this one question sparked by Professor gave rise to this birth of this multi-round strategies. In fact, I would say after this paper got published, several people started using this multi-round strategies, variants of this in different ways. So the following key question would be how to formalize this whole thing. How do we start formulating the problem and derive an expression for the total finish time? Now, unlike the first case where you just send it by one shot, my next 8 months time, busy time was kind of initiated once this key question was asked. So here in this strategy, and obviously there are two parameters came into play. The one is platform scalability. Suppose if you are given larger number of nodes, so if there is no limitation to increase the number of processing nodes, then definitely it is something like you can minimize the time. But what if the size of the infrastructure, the platform is limited? Then by increasing the number of installments, the rounds, then that will also equally reduce the processing time. So as you could see, the timing diagram, there are different installments, and in each installment, the processor is assigned different amounts of load. And we try to use the property of optimality, which we proved for the single installment in the last stage of the entire process by forcing the process stopping at the same time, and then derived all these load fractions and the processing time. So this was a very major exercise for me in my second year, almost 1993. Most of the second year, this was occupied, together with another problem which I solved using a different network topology, which I'm not presenting here, but it was there. So this was kind of a very use-inspired, plus this strategy was able to optimize the resource. So if someone is not able to allocate more resources, then we always have a mechanism to optimize the time by increasing the number of installments. So that was a very use-inspired strategy. So the tangible outcomes that benefited my career progress all along, because my PhD, I started in the year 1992 January, and I completed sometime 1994 April, and I believe it's a lot of work was carried out. I mean, Prof. Debashish and Mani were fully convinced that there was enough substance for me to complete my work. So the tangible outcomes that benefited my career progress, 3 solid journal publications in a span of 2.4 years, and that's not. We started getting consolidating all the works until the day 1994 into a book. We call it as a monograph, and it was published by IEEE Computer Society. So this writing work spanned over almost 1.5 years, I would say. Like, I was doing my postdoctoral research in Concordia University. So during that time, I was fully in touch with Prof. Mani and Professor Debashish. And there was another author, Professor Robertazzi, who became a very good friend after I graduated. And his works, I mean, in fact, he was the person who initiated this whole modeling and all that in the numerical methods way. And he was also happy to contribute to our book and be consolidated and published this book in 1996. So till date, this was probably the only book available if anyone wants to jump into this area of data parallel computations and schedulers design. And this till date has secured several citations. And let me take this opportunity to highlight some of the other works by Professor Debashish. And these works, I think he has done with Dr. L. Anand. Dr. L. Anand was my junior in the EC department. And then he was a very passionate researcher. And in fact, he was asking me in the year 1992 that he expressed his interest to join PhD, and he was asking about Professor Debashish's research and all that. And I was telling him the work and the way he guides the students and all that. So then he got interested. So I introduced him to Prof. Debashish and Mani, and he also went through this entry process, and he got, and with him, I think the team had a different intake. So although they worked in distributed systems again, it was like more on a load balancing problem. So which says that, okay, so it's not that the load is not assumed to be divisible, but the loads are kind of more of independent loads. And so how do you balance this assignment of loads across the nodes on a network? And that was their objective. And with Dr. Anand and Professor Mani, Debashish, and the team kind of used lots of queuing models as they could understand. And then they were also talking about some resource availability maximization problems where they had shown, I think they also used nonlinear optimization techniques and all that. So it was kind of a different approach that was given in the distributed systems domain. The next work, which, I mean, after I joined NUS in 1998, I was actually tracking all these works in the area of scheduling and distributed systems. And in the year 2002, I could see one striking paper from Debashish Ghosh in the conference PDPTA.
I apologize,
And
Professor.
this was in,
Hello?
yeah.
Yeah, I apologize for the sudden interruptions. Dear Professor, due to time restriction, can you conclude the talk within 5 minutes?
Sure, I'll do that.
Yeah,
so
yeah.
this was.
Yeah, I apologize again,
So,
sir.
sure, no problem. So this was in computing in blind environment. So another question he threw is that, what if I do not know the speeds of the nodes and links in a network system? So that was his idea. So he came up with a strategy, just like a strategy where you try to measure the time between a probe load, which is sent to a node, computing node, and measuring the time difference, and then trying to estimate the speeds, and then using it in the distribution strategy. So likewise, he has contributed several works, and I carried out these type of works and actually implemented these on variety of application problems. The first being image processing, where I tried to look at some edge detection applications and all that. And then I extended it for bioinformatics applications, and then to use divisible load models for handling SAR data processing. And we actually implemented on some parallel clusters. Okay, so, and then we could see a significant time improvement, and not just alone the time, but also using the visual quality output. So, which is like if I increase the amount of load and use multi-round strategies, I could see the visual quality of results significantly increased. And there are several other people who have used this load distribution techniques for data parallel applications and have benefited. Well, takeaway points, some landmark achievements, I would say a very formal treatment was introduced, and then explicit closed form solutions, proof of optimality, and innovative strategies towards resource optimizations, and several use-inspired practical demonstrations where actually they followed after 1994. Well, the modern day application domains include energy versus time trade-off studies when someone tries to implement these strategies on modern day cloud or HPC platforms, satellite image processing applications. And currently, as we speak, I'm trying to use this type of techniques, divide and conquer techniques on computing and communications on satellite constellations. We have a satellite research center here in NUS where our students actually fabricate micro and nano satellites and put into space using India's launch pad, Sriharikota. And the other area is signal processing and federated learning approaches, which I'm looking at, which could benefit divisible load approaches. Well, the final remarks is like my PhD journey, a very eye-opening experience. And Professor Debashish, I think a very good, on three categories, I could say that as a friend, I could give an example, quick example. So if many of you would remember this, so there is a E-block hostel, and there is a road separating the guidance lab and the E-block hostel. And that's where I was standing on my first day after the PhD enrollment. I could see Prof. Debashish coming. And then he was asking me gently, I was asking him, like, how do I go to the department, to the lab? And he said, like, he was pointing, like, you have to go all the way up and then turn, and then you can see the entrance of the control lab, aerospace department, then walk back, and that's where you come to this lab. He was pointing to this lab. But then I was a bit, whoa, it looks like a lot of walking. Then he was putting a gentle smile, and then he was just pulling up the barbed wire, and then he was entering. So that was a 20 seconds walking time to the lab. So that became almost a permanent entry point to the lab. And as a guru, I had learned so much in guiding a student. In the interest of time, I couldn't share anything, but he could, take this, I could see this, he could take all the sense of responsibility on him, and then pushing me to think through the things very carefully and putting some very standard practices in research. So I was exposed to a variety of research practices. And then as a common man, he was able to discuss all the worldly affairs during our coffee time, walking towards India Coffee Board at the time. I hope it's still there. And I had a lot of talk. In the interest of time, I couldn't share many things, but that was there. So here is a small proposal to Professor Debashish. So if in the days to come, probably, I don't know whether IISc has this way of handling the research students across campus. Here in NUS, we have a research course just for 2 units. Every PhD student is supposed to take that. And precisely these are the topics they do, like how to start doing a PhD. Okay, and then common pitfalls and do's and don'ts. Probably with Professor Debashish's very rich experience with a bigger sample size of students, I'm sure he could write a blog which can permanently, a primer, which could permanently stay on aerospace department's website. And every student, I believe, can hugely benefit. So I wish him good luck and a very healthy living in the days to come. And I'm sure he will continue to contribute to the scientific domain. Thank you very much for giving me this chance to share my journey. I'm sorry I couldn't talk more because the time is quite limited. Otherwise, I had a good number of examples for these three categories: as a Debashish, as a friend, a cool guru, and as a common man. Thank you very much.
Thank you, Professor, for that exciting and memorable talk.